Have you ever wondered how an email gets from your home in one country to a friend in another? It does not fly through the air or get beamed up to a satellite. Instead, it travels through long, thin cables lying on the bottom of the ocean. These are called subsea cables. They are the hidden highways of the internet. Over 95% of all international data travels through them. That includes everything from your video calls and emails to the movies you stream online. These cables are the true backbone of our connected world, making global communication possible in an instant. They are a marvel of modern engineering, connecting continents together. These amazing cables are not very thick, most are about the size of a garden hose. Inside, though, they are packed with incredible technology. They contain tiny strands of glass called optical fibers. These fibers are as thin as a human hair. They carry information as pulses of light. A single modern cable can carry hundreds of terabytes of data every second. To put that in perspective, that is enough capacity to handle every single phone call being made on the entire planet at the same time. The total length of all these cables is nearly 1,000,000 miles, enough to circle the Earth many times over. The importance of these cables to our daily lives is huge. Think about the global economy. Every day, an estimated $10 trillion in financial transactions zip through these underwater networks. Banks use them to move money around the world instantly. Businesses rely on them to connect their offices and serve customers everywhere. When you talk to a family member on a video call across the ocean, you are using a subsea cable. Without them, our world would slow down dramatically. The instant communication we take for granted would simply not exist in the same way. The system is more than just the cables themselves. To keep the light signal strong as it travels thousands of miles, special devices called repeaters are needed. These are placed along the cable every 50 to 62 miles. They act like amplifiers, boosting the signal so it does not fade away. At each end of the cable, on land, there is a landing station. These stations provide the power for the entire system. They also connect the undersea cable to the regular internet networks on land. It is a huge, complex, and vital system that most people never even see. Making a subsea cable is a very careful and precise process. It starts with those hair-thin optical fibers, which are usually made in the United States or Japan. These delicate fibers are the core of the cable. They are carefully placed inside a metal tube, often made of copper or aluminum, to protect them. This tube is then surrounded by strong steel wires. The steel gives the cable the strength it needs to be pulled and laid across the rough ocean floor without breaking. It is like giving the fragile fibers a suit of armor to wear on their long journey. After adding the steel wires, another layer is applied. This is a copper sheath that conducts electricity. The landing stations on shore send electricity through this copper layer. This electricity powers the repeaters that are spaced out along the cable's length. Without this power, the light signals would become too weak to read. Finally, the whole thing is wrapped in a tough plastic material, usually polyethylene. This outer layer protects the cable from seawater. It is a multi-layered design, with each layer having a very important job to do to keep our data flowing safely. For cables that will be laid in shallow water, extra protection is needed. In depths down to about 1,500 meters, the biggest risks come from human activities. Fishing boats dragging nets and ships dropping anchors are the two most common causes of cable damage. To guard against this, the cables get even more armor. They are wrapped in one or even two extra layers of heavy steel wires. This is called single armor, or double armor. This makes the cable much heavier and stronger, helping it withstand accidental impacts from ships and fishing gear. Laying the cable on the ocean floor is a huge job that can take months. Special ships called cable layers are used for this task. In shallow water, the ship pulls a large underwater plow. This plow digs a trench in the seabed, and the cable is carefully laid inside it. The sand and mud then cover the cable, burying it for protection. In the deep ocean, where the risk of disturbance is much lower, the cable is simply laid directly onto the surface of the seabed. The entire project, from planning the route to the final installation, can take anywhere from 2 to 4 years to complete. In the past, subsea cables were usually built by groups of telecom companies working together, but now, there has been a big change. The biggest players in the internet world are taking over. Tech giants like Google, Meta, the company that owns Facebook, Amazon, and Microsoft are now the new kings of the subsea cable industry. They are sometimes called hyperscalers. Their massive data centers all over the world need incredible amounts of connectivity to work. As one expert said, without these cables, a data center is just a really expensive warehouse. These companies now fund about half of all new cable projects. These tech giants are building some of the biggest cable systems the world has ever seen. For example, Meta is a major partner in the 2Africa cable. This massive project is over 28,000 miles long and connects 3 continents, Europe, Africa, and Asia. It is designed to bring internet access to millions more people. Meta is also planning its own private cable, called Project Waterworth. At 31,000 miles, it is set to become the longest subsea cable in the world, spanning 5 continents. These projects show how serious these companies are about controlling their own global networks. Google is another major investor. The company has put money into more than 30 different subsea cables to connect its vast network of data centers and serve its users. One of its recent projects is called Soul. This cable connects the United States with Spain, with stops in Bermuda and the Azores Islands. Amazon, through its cloud computing division AWS, is also building its own infrastructure. In late 2023, Amazon announced its first fully private cable named Fastnet. This cable will create a direct link between the state of Maryland in the United States and Ireland, boosting connectivity across the Atlantic. The demand for data is growing faster than ever, and a big reason for this is artificial intelligence, or AI. AI systems require huge amounts of data to be trained and to operate, and that data needs to move quickly between data centers. This is fueling a boom in cable construction. Investment in new cable projects is expected to reach around $13 billion between 2025 and 2027. That is almost double the amount spent in the 3 years before. This huge investment shows just how critical these underwater highways are for the future of technology and AI. While subsea cables are incredibly powerful, they can also be surprisingly fragile. Each year, there are between 100 and 200 incidents where cables are damaged. Most of these are accidents caused by fishing boats and ship anchors, as mentioned before. However, in recent years, there has been a worrying increase in suspected sabotage. These are not accidents. They are deliberate acts to cut these vital connections. Experts call these gray zone tactics because it is often very hard to prove who did it. This allows hostile countries to cause disruption while denying they were involved. There have been several real-world examples of this. In September 2023, several cables were cut in the Red Sea, which caused problems for Microsoft's cloud services in Asia and the Middle East. In the Baltic Sea, officials in Germany, Sweden, and Finland are investigating damage to 2 different cables as acts of sabotage. Near Taiwan, a Chinese ship was detained after it was suspected of cutting a local cable. These incidents highlight a new and serious threat to our global internet. The physical security of these cables is now a major concern for governments around the world. In response to these threats, governments and military alliances are taking action. For example, in January 2025, NATO launched a mission called Baltic Sentry. This operation uses ships, drones, and aircraft to patrol the Baltic Sea and monitor for any suspicious activity near important cables. The United States is also tightening its rules. It is now blocking new cables from connecting directly to countries it considers adversaries, like China and Russia. The United States is also banning hardware from certain Chinese companies, like Huawei, from being used in these networks because of security fears. Cable companies and manufacturers are also developing new technologies to protect their networks. To avoid service blackouts, they build multiple redundant routes. If one cable is cut, data can automatically be rerouted through another one. They also encrypt all data to prevent spying. A fascinating new technology called Distributed Acoustic Sensing, or DAS, is also being developed. This technology can turn the cable itself into a long sensor. It can detect the vibrations from a nearby ship or submarine, acting like a sonar array. This could help companies detect threats and protect these essential lifelines that power our modern world.